Okay, I'm back. Yeah, I solved the last problem. But if anyone is watching this stream because they wanted to know what followed, I'll show you what the reason for the kink was. So here's I had a discussion with Claude, who is not helpful, but it just puts my own thoughts in black and white, or white and black. So my theory was, let x be a random number between minus 100 and 100, using a precision of 128 bits as in the program. Let d be a double that x is assigned to, rounding it off, aka imperial x is some random number, and then we assign it to a double. Then ada, which is then the difference, or the rounding off error, divided by the absolute value of x rounded down to the nearest power of 2 is uniformly distributed. For each region, for an x uniformly distributed between 2 to the power k and 2 to the power k plus 1. Note that for each such region, 2 to the power, the floor of the log 2 of the absolute value of x, aka the rounded down to the nearest power of 2, is obviously then 2 to the power k. Because if x is between 2 to the power k and 2 to the power k plus 1, then rounding it down to the nearest power of 2 is just 2 to the power k, which is constant for this region. And therefore the uniform distribution here comes from the fact that d minus x is uniformly distributed for such a region. And namely, it's distributed as 2 to the power k times the uniform distribution between plus or minus a half the machine epsilon. Hence, for any such region, or a portion thereof, eta is distributed as between plus or minus a half epsilon. Because okay, now I made a thought jump here that I cannot follow myself now. Yeah, of course. So dx is uniform distributed as this. That's that one, and then we divide that by 2 to the power k. So eta itself is then distributed as this thing divided by that 2 to the power k here. So that is then uniformly distributed between these two. And it doesn't really matter what x is, because this is always uniform, and whatever k x you pick in whatever region, this is always going to be the correct 2 to the power k factor that you have to remove from that distribution for each interval, depending on k then, but after dividing it away, it's gone. So we have exactly this. And I tested it out, and that is indeed what the program shows, a nice uniform distribution, no matter what uniform range x falls into. However, the original problem that produces the empirical data, shown in the image, aka the one with the kink in it, divides by the absolute value of x, not by the rounding it down to the nearest power of 2, but by x itself. Which means that all samples are made smaller by dividing through x instead of x rounded down to the first power of 2. Yeah, the x is larger than rounding it down, so the whole thing becomes smaller. Hence that the probability distribution narrows, it becomes more centered around 0. And that's why you have the tails. And then I think Claude actually got it. Or not. No, I didn't. So it says, I'm getting stuck. Can you tell me if this was at least in the right direction? And I say, no, not on the right track. The conclusion of the above is that x is uniformly distributed. If x is uniformly distributed between 2 to the power k and 2 to the power k plus 1, or a union of multiple such regions, in particular between minus 2 to the power k and 2 to the power k, then the result should be as predicted, and it is. So we don't have a kink. The reason for the deviation is that I used uniform distributions between minus 100 and 100. Well, 100 is not a power of 2. Can you find the correct formula that derives 0.32 from that 100? And it did that. The 0.32 is, comes from this, where the 64 is the rounded down power of 2 of 100. Meaning that we only have a portion of the region between 64 and 120. And it says something that's inaccurate, so I fixed that, and I said, so the crossover point at 0.32, aka where the kink is, comes from the fact that if the absolute value of r is larger than 0.32, only a part of the 64 to 128 range contributes, and that is, we are missing all the values from 100 till 128. And since eta is proportional to the inverse of x, it becomes larger on average. So that's why it rises above, so beyond the 0.32, it becomes a bit larger, and then the rest within it has to become a little bit less, because the service must be 1 for the PDF. Okay, so having solved that, I was now going to fix my article here, which I already did, is a linear actually. So I added here that if x is truly random, uniformly distributed over one or more intervals that go from for some k to the power k till to the power k plus 1. Where's my cursor? Maybe probably should say sum. And the probability distribution of eta is as we calculated. And I want to insert a graph here so we can see how it looks. Let's ask Claude how to do that. I'm gonna start a new thingy though. How do I include image into a logic document. What is it? Right, let's begin with creating that image. I think I had it in GIMP. Now let's make a new one. It is without the distribution. I'm going to use line color black. No, what the heck? Just use a thin line, thin black line. And I don't want to add this line here. Though now I get, well, it was probably stupid in a minute. Now let's just comment all of this out. Where is it? It's still doing stuff. Why? No, there it is. Yeah, I need better labels and a better title. Let's begin with the labels. What is a good label here? Or can I? I don't know. Yeah. To do the. I think label. Yeah. Damn it, I can't have mu. Just write it like mu. No. I don't know. Maybe I should have no level at all and just add a level in Git, in GIMP. I mean. Mm-hmm. Yeah. I'm not sure. Probably still. I mean, I need to make it smaller, way smaller, and then we just need thicker lines and everything. Let's do this again, but then with a thicker line. One color. Heck, let's just start smaller. At the very least, half the size of this. It's hard coded, holy moly. No, no, we have absolutely horrible. Labels there. That's not good. Okay. Can work with that. Well, I need this space. I just want to get a white part. Probably. Clip, or what is it? Image. Crop to selection. And then it add some text. So horizontally we have this can't be right. Color black. Type something. It's too big. So maybe 16. What? It's at the top. Cannot delete this anymore. This looks like a layer. Yeah, empty text layer. Delete, 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 delete. I don't see the delete. Delete. It should work. Just delete. No. Delete here. No. Delete here. No. I gotta delete here. Blah, blah, blah. Delete. Okay, now I have to insert eta, which might not even exist. In this font. Yeah, I have an eta. Hello, TT. Can you prepare group again, please? Your YouTube channel is the Discord page. I only to join you. I have no idea what you're saying. You say Discord and join. The rest is horribly translated from whatever language it is. I'm gonna guess you wanna invite to Discord again. I can't get it to be copied, it seems. Damn it. Yeah, that link never expires, so keep it safe and you can keep inviting yourself. I want to type here the PDF of mu. Oh, eta actually. Eta, I got my eta from here. Seriously. God. Tiresome. So you don't have a superscript K? Superscript K. Or how do you type that in here? Well, I have no idea, so I'll just probably have to get the superscript case from somewhere. Super or script. You only have an N. There is absolutely no superscript. Okay, I'm gonna put an N then. Damn it. Yeah, and now that again. Now we don't have a superscript plus there thus apparently. Nope. Oh yes, plus. We do have a plus. Gets higher and higher. The N is not really at the right height, if you ask me. But hey, we can't help it. Okay, and how the hell do I rotate this thing? Well, it's a layer. Maybe I should separately rotate it. This looks like a move. Shift is doing nothing. I don't know how to rotate this thing. Shift R. Okay, 90 would be nice. Oh, 90. And I move it. Probability function. Wait a minute, it's the probability density function. I'm gonna call that one mu. Do I need my mu again? No, add, damn it. Copy. Better do this, and then we have key impair based add a probability density function. Anchor. Nobody knows how to anchor this thing. But they're all separate layers. Apparently. That will work. Yeah, it's still big. Like way big. Let's write this away. Save as. I'm gonna save this as I'm gonna assume that I can do the scaling down in LaTeX. Let's see if it works. If I just put the file name here instead of the whole path. What the hell? Oh, here it is. There. Compilation failed. Not again. What is wrong then? This is logs. No error. Error. Missing dollar inserted. Check 30. 30 and 31. That worked. Escape. Okay, it says here, see figure 1. I'm going to assume that I need a dollar here. Oh, I'm back. Yeah. Right. So. Plus and minus. I think it just gets smaller the further away we are from the rounding off thing. It's smaller, so that is the rounding off thing divided by x. Still going to use the plus or minus epsilon here, not put a factor in front of it. Where is my epsilon? I need a bigger keyboard with epsilon on it. Insist on, I think I have it in my appendix. To be here. There, that's what I was looking for. Copy this. Okay, x divided by the rounded down to the nearest power of expression, which I also have a billion times. If x only spans a fraction of a power of 2 range, as is the case when approaching a root using Halley's method, then the distribution is again uniform. U is, well, whatever, it's stuff with absolute value of x divided by the 2 to the power of the floor of the log 2 of the absolute power of x times a uniform distribution on between minus half epsilon till a half epsilon. So let's predict what that would give for something. Let's make a uniform distribution which runs from, let's see, on the down, yeah, so it can be a whole factor of 2, but no more. So it must be somewhere between a quarter and a half. Let's deliberately put it exactly at 0.4. That means that you need a factor of, well, 0.5 divided by 0.4 is 1.25 times some power of 4, let's say 64, is 80. So if you use, I'm gonna kill GIMP. I think I can go kill it, but let's find it first. Quit. Yeah. Let's change this back to what it was. It's not displayed. This is not displayed. You can't do that. But well, can't help it. So if I use 80 here, we go from 32 till 80, then it should give me a uniform distribution. No, that's nonsense. Huh? What? No, it should be around 80, sorry. Okay, so this must be 0.999 or something times limit. So that is a random number around 80, or a very narrow band. Yeah. And it should give me a probability distribution from minus 0.4 exactly. till 0.4. If I was drawing it, that is. Yeah, sharply 0.4. I think we completely mastered this this stuff. I now know how this works. I'm an expert. So next we can finally continue with the real stuff. Namely, yeah. So like 24 hours ago, I was trying to plot the distribution of the eta that belongs to this one here. We have this eta 1. So we have, yeah, I want to see the probability distribution of this eta 1 here. For, let's say, we begin with a random axis. Which means that I'm changing this back to some power of 2. And then we go over a number of full power of 2 ranges. And then we calculate the square of x. And then we assign that to d1, because that's what's called d1. It becomes the square root of x. And then we calculate the eta that belongs to that. So that would be the assigned value minus x. Or rather d1 minus, not minus x squared. This is nonsense. Okay, this is now eta 1. Hmm. Hmm. So it's again a tiny little bit deviated from the really random x, which makes sense, I guess, because the square of x is no longer uniformly distributed, is it? No, probably not. So if instead I would do what I did before, I'm not doing the square, but we're doing x times another random number. I would think that this is indistinguishable from just random, right? Not sure though. Whoa, totally not. It's even worse than the normal square. Hmm. You know what? I think this might not even be super interesting. It is indeed more interesting to look at narrow bands of random numbers. And I might as well pick 100 and then do the narrow band around that. No, wait, let's use, no, okay, well, I had a 0.4 thingy, but I want to have, .5 divided by 0.3, let's do that one. It's 106.6666. Can't do that. How about I can make a larger number, okay. Wait a minute, I can't use 64 anymore now. Huh? No, I'm very curious what this gives. Which maybe have to round this down to the nearest power of 2 and use that here. But then the 100,000 must go. But maybe this is the same thing, because it feels like it should be. Absolutely not. Oh man. No, what's more shocking though, it's not a uniform distribution. Pretty shocking. Oh, wait a minute, I'm doing the square again. Let's do this first. Oh, I was multiplying with the full range. Blah, blah, blah. Probably not even needed to get this narrow. Go back to that. Okay, yeah, it is uniform, but not at 0.35. I want it to be here. But okay, we can just use some this many digits and then find the power of 2 by running that down. How big is the thing? It's 10 million. So I need a log of that divided by the log of that 2 to the power 23. Now this is gone then, and here this is 2 to the power 23. Which is and it's larger than 10 million. What the heck? Wait a minute. It should be less than 2 to the power 64, isn't it? Excuse me, the 2 to the power 33. Yeah, significantly. Well, it makes no sense whatsoever. Why am I having 32 there? There's no way that that is what it is. I forgot what it was though. Okay, I'm gonna do the ln of 14680064 divided by the ln of 2. Yeah, not 32, 23. And then 2 to the power 24 is 16 million, which is a lot, and then 14 million, so this should work. Nah, it doesn't. So I was aiming for 0.35, yeah. Instead you get that. Why? Hello fun memes. How the hell is this not working? No, because I can't calculate. 11983725. Okay, now it should cut off at 0.35. Yes. Yeah. 0.35. And I think this is a better statistics. Having just an x that is, yeah, in a narrow band, basically. And I'm going to calculate the square of that, or let's first just multiply it with a similar random number. Almost a square, but with different rounding off error. So that should give, I think, a triangle distribution. No, I don't know. I'm clueless. No, probably still uniform. Yep, uniform, but way wider. Which is also logical, because what? I guess 0.35 squared is a lot closer to power of 2. Yeah, 0.1225, so it's almost 0.125. So instead, let's use then the square root of 0.4 here. So the square root of 4 is, no, that's impossible. It's larger than half. Maybe the half of that. Let's try that. So half divided by the square root of 0.1 must be less than 1, and I guess larger than a half. So like that. And then we can divide left and right by half, or the half is always constant. How do you do that? Let's multiply this with 2. And then do 1 divided by, so this stays 1. So it must be between a half and 1. So it's very well that this now cut off at the square root of 0.1. Which is, the square root of 0.1 is 0.316. Yep, so this is 0.316 here. And then if we multiply that with some other random number around that point, then we expect to get I have no clue. I was heading for something, but what? Oh no, well, a nice number anyway. Yeah, 0.4. That's definitely a nice number, right? That's what I was going for. Probably this distance here is the 0.1 that we used. But what happens now if we multiply the thing with itself instead of with another? So 2 random numbers now gives a uniform distribution between plus or minus 0.4. And now we do the square with itself. Is it still uniform? That is the question. It's still uniform. Wow. Okay, so it doesn't really matter then if you multiply it with another random number or with itself. I think I made a mistake somewhere, because this is already running from minus half to plus half. Or this is relative to epsilon. What am I saying here then? Yeah, this is not eta. This is eta divided by epsilon. Oh my god. I have to make a new picture? I think that was correct. Yeah, see, eta is between plus and minus half epsilon. So eta divided by epsilon is between minus half and a half. Why the hell am I talking about mu here? It's also a brain fart, I guess. For the rest, everything looks okay. Let me see. This is again uniform. This must be eta. God, I hate it when there's no eta when you need it. I'll just stop eta. Eta. But yeah, this is more difficult. I have to start up GIMP again. Fortunately, I didn't merge didn't merge the layers, so it's actually pretty easy to correct it. As long as I could find my epsilon here. Copy epsilon from here. I have to start GIMP from here. Nope. From here. Nope. Don't tell me I do not have a tab open. Oh, it's here. No GIMP here, no. GIMP. Screenshot. .xcf. And then we have this data here. Now we must edit it. Need that one, of course. Divided by is still here. Paste. Yes, it's still there. Add the divided by epsilon. That's what we need. And I can move it. Put it in the center again. That was already more or less in the center. Yeah, and I can leave this at that. I think doesn't matter. Epsilon being a constant. This doesn't change if you scale it horizontally. You can also leave that one. So we can do save and then export. It asks me to override this thing. Nope. Export. You want to replace it? Yes. And then we should be able to quit here. And then regenerate this thing. Yep, now we have a eta divided by epsilon. Really cool. Okay, so at the moment we calculate d1, we know x, otherwise you can't square it. And the error is then simply the probability density function of eta 1 is a function of that known x, because it doesn't really matter what it is exactly. Anyway, we're already pretty close. It's actually a function of the d1, but d1 will be close to x. That's, well, actually, notice, well, yeah. d1 will be close to x squared, I mean. So in this case, x was axis around this value, which is this. So the square of that is then now more or less, because now it's random, but pretty close to limit. Yeah? So this is then more or less the square of this. Which is 0.5, because we need to keep that, divided by 0. How does the square root of 0.1? 3, and then square root of 0.1 is 31622. 7766 times 2 to the power yeah, must be 46, huh? No, I got rid of this half. So this must be a half squared. But I want to write a half, which means that we have to subtract 1. 1 is 45. Yes. This is complete bullshit. The log 2 is I'm talking this not complete bullshit. Sorry, it's a log 2, yeah. It's 2 to the power 45, not 10 to the power 45. That's getting so senile, it's not funny anymore. Okay, so, well, the remark here is then that the floor of the log 2 of the limit squared is 45. There's no where here. Okay, now we have to get from the 0.3162277766 to 0.4. How did I do that again? What was it? 10 is a half times 60, 41 divided by R. That was, I have no clue. I forgot it. Just a pure memory issue here. No, it's not. I made a mistake. This is the square root, but we have just squared it, so now it's 0.1. Yeah, that ain't working, because 0.1 is not between a half and 1. So we have to multiply this with 2, and again with 2, and again with 2. No, just twice would be nice. Then I get 0.4. Oh, this is bullshit. This was this is 0.3. Definitely not between a half and 1. Because it must be between a quarter and a half or something. The problem is that this number must not change the fact that the total result rounded down to the nearest power of 2 must still be this. Okay, so this number must be larger than 1 then, and maximum between that number, yeah. So we need that it must be larger than 1, so we can round it down. So I started off with a half. That was wrong. It must be like that. If this is between 1 and 2, then the total number rounded down to the nearest power of 2 is going to be exactly that. So now I can multiply this with 2 here, and this one with 2, and this one with 2. And then inverter stuff. So then we get 0.25 is less than the square root of 0. Yep. Is less than 0.5. See, it's a quarter and a half. And since 0.1 is not less than, not between a quarter and a half, you have to multiply this with 4 in order to get there. And then add 2 to this power, right? So this becomes now a 7. Just shifting the power of 2 range. And now nobody can follow it anymore, so maybe you do it in 2 steps. I mean, nobody in the future. So that's simply the square. Okay. And we expect this to have a PDF uniform between plus or minus 0.4. That was easy. Yep, 0.4. Well, yeah, we already saw that. Okay, so in general, that isn't as easy. So I'm going to do the D1 thingy here. Rotor here. And the rest, and then we can explain that D1 I'm not going to repeat it. Let's just invent a new abbreviation here, which is so obvious that everyone will understand it. I'm just using u or plus and minus. So I have to only do it once. Okay, so I have to do it differently. So my eta 1 is equal to this, where this is now a constant. So if I multiply eta 1 with the absolute value of x squared, then we get this, which is uniformly distributed between plus and minus a half epsilon. So let's say I'm gonna do the frac here. Well, let's use a complete new formula actually. Arg. We're out of equation. Okay. Begin equation, end equation. So we know that eta 1 divided by the absolute value of x is uniformly distributed between plus and minus a half epsilon. What was I doing? Plus or minus, yeah, a half epsilon. Something is not correct. It's totally not correct. Sorry. No, what we know is that this thing divided by... Huh? This divided by the absolute value of x squared rounded down to the nearest power of 2 is uniform between that. So if they multiplied with that to get this, and then divided by, okay, so that's nonsense. It's dividing here. You have to multiply it with that. And then divided by C frac, just frac. Two to the power the floor. No, that's not how it worked. Floor. Just this thing. 2 to the power of the floor, but then I want x. So 2 to the power of the floor of the log 2 at absolute value of x. I probably can make a LaTeX function or something, right? So you can just Don't have to type this all the time. Paste it all the time. Hmm? So add 1 times x divided by to the power of the floor, the log 2 epsilon power of x is uniform distributed between plus and minus a half epsilon. But this is already so not super logical that I might as well skip ahead and bring this to the other side. Plus is not x, it's x squared. So yeah, I'm going to write here oops, now for the squares again. Probably should talk about x squared here as well. Some kind of a search replace thing. So since we know the approximate value of x squared, we also know that eta is uniformly distributed between plus minus a half epsilon times this scaled to this factor, which lays between a half and 1. But yeah, the we know here comes from the fact that I have a super short remark here saying if x only spans a fraction of a power of 2 range, as is the case when approaching a root using Haley's method, then the distribution is again uniform. Namely, I don't know how to pronounce that. It's a tilde, but I would say it looks like proportional width, but it's not what it is, of course. This is uniform distribution. Plus, this looks totally different than what I expected. I think this is wrong. So it should be the other way around. This makes it larger, which is impossible. Okay, how do I add a label? To EQ. Okay, maybe that should be indented. Mm. Yeah, I really hate to add the absolute value here, because x squared is always positive. It just looks silly. No, the exact same can be said about D2, or rather add I2. So I get something like okay, for now I'll just add no number after everything. I added another one somewhere. Where was my new formula? Maybe it was this one, but I am referring to it. No, it was another one. Damn it. I added something. Don't see it. Okay. Yeah, now we need an abbreviation for this. That's obvious. Let's not yet abbreviate that one then, the U, and just make an abbreviation for the whole thing. It's more like minus that, comma, plus half times that. Then same thing here. Maybe now I can use the calligraphed U, which I forgot how to do, obviously. Let's see. Where do I go here? I meant to say, oh, what am I doing? This one. Hey. Oh, just can't copy paste this stuff. Good. But what is eta 3? I'm getting beeps on my headphone, and I'm pretty sure it's chromium, but there's no way to find out where they come from. Of course, they only occur not that often. So infuriating. Dit is what it is. Yep, that was a beep again. This is the music on my headphones. It's very soft. It claims it is very soft. Well, it is not. I can make myself completely deaf probably by having that come here. So I can do this, and now we have another slider here. Ouch, my ears. What I probably should do is put this one higher. this is a volume. And all this time, no beep. Okay, I give up. Don't beep every now and then. Can I store it in a range or something? A range stores doubles. Well, they are doubles. Yeah, prints it even with square brackets and everything. So I want to use a range for the limit. It's called X. No, it's another X range. Random X range. There's another X range. It's the horizontal range. It's not X then, though, right? Well, no, not really. This is the eta range. It's not even the eta range. It's the eta divided by epsilon range. Epsilon. Cairo window range. It's so non-mathematical. By the way, I do have it here, but it's only because I also want to draw. So it's kind of weird to use a Cairo window range, I think. It's totally weird. Da-da-da. Yep, there it is, and the 0.4 is still there, and now we have stuff here. Yeah, whatever. Oh, yeah, this is again eta divided by epsilon. Still wrong. Tick tick. I didn't know I could make that. I mean, it shows it. Thought I would get a little square or something because it couldn't draw it. Suddenly it can. Divided by epsilon. Hey! Oh, I hate doing that. That's it. I want to press Control Tab to switch from this tab to that one, but then accidentally I tap Alt Tab. So I go to another, completely other window, in this case the browser. And then I press Control Tab anyway. But now the Control Tab acts on the browser instead of on this console here. Yeah, I just jump thinking I close the top, but I just switch it up, so it's not totally a disaster at all, actually. It is not a total disaster. In any way, but I'm still like, oh, what happens? What did I do? Right. Next. What shall we do next? Yeah, I'll have to go to D3. Oops, that's not the one that I want. Okay, let's recreate the cubic again, or get the cubic. And then the formula was wrong. It says x here, it should have been x squared. What to do with this? It was just a intermediate scratch pad thingy, yeah? Maybe I should just delete it. I have my PDF now for that. I can do this. Yeah, I guess that is correct. Maybe I should print the expected thing here, but won't work. Yeah, I need these things too. Just not add, maybe? Not even sure. what do I need? D1 or that's what I'm using. This is how I calculated broader, because here the eta is defined relative to the mathematical expression. Probably should do C3 times x squared. Think. Just call this one then x squared as well. I do round it off though. But this is eta 3. So here I should, I think, look at the difference with relative to I think this. No. Because, well, if I do that, I get eta 1 plus eta 3. I think maybe that is what I should do. I don't know, man. It's too dark. I can't see my keyboard. There it is. 3 times that is, yeah, it's the formula. But yeah, this is now eta 1 plus, well, whatever this is here, 1 plus 3. Which theoretically could be larger than a half as well. Totally uniform. Strange. Why is the thing uniform? Mm-hmm. Yeah, that is because I did use C3 times X2 here. There is no difference with D2. It's not even a function of D2. So the whole eta 1 is not present in this eta. But this is incorrect because we don't have this. We never have that. The only thing we have is... Well, we don't have this. We don't have x squared. I can't multiply this with x squared. So the rounding off is wrong. I mean, I can calculate this. Do I know what the exact value is? But I also have to calculate C3 times the x squared that we actually have, which is D1. Which then should end up as being this value, introducing its own round-off error. So now D3 is calculated as C3 times D1. C3 times D1, introducing a new round-off thingy at S3. And then I can calculate eta 1 plus eta 3 from the difference between the mathematical value and the thing that we got. which is then this. But now add one did sneak in, so now it should not be uniform anymore. Yeah, I think that's how it should be done. Compile. Oh, yeah, now it's larger than half. Good, 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 good. So maybe I should start accepting stuff larger than half now, or no, I can't. I have to change my buckets now. Guess we should try from 1.0 till 1. No, maybe triangular. I hope. Totally triangular. The height is a lot higher here, though. I think I'm dividing by the wrong thing. This surface is obviously too large, right? It's not 1. So this is 1, and the corners go to, I guess, -1. So the width here is 2. So the height should be a half, but then half is gone, so it should be 1. The top here should reach 1 here. Won't be more than 2. So what am I doing wrong then? First of all, my X range is wrong. This range, yeah, this should be equal to the range of the buckets. So let's see, buckets. They just have a min and a max value here. Just return a range as well, why not? Yeah, still don't like it that my range is part of namespace career window. Should that be moved? Is that the mathematical thing? Okay, never mind. I'll just use min value and max value. Now let's replace this with a count scale. Let's see how does this work. Define that here maybe. It's gonna have a double count scale, which is currently equal to this number divided by the loop size, but those are both integers, so that doesn't work. Just cast one to a double first. I'll just multiply this with count scale. And this cast is no longer necessary. However, now the range, we have to go to basically the largest count times count scale. So count scale times largest count, which we can get from buckets. So maybe max count or something. Buckets. Max count, yep, exists. But now the count scale is still wrong. Oh, what should the count scale be? I guess I have to divide it by bucket's width. Let's see, the number of buckets divided by the loop size. It's the number of counts per. It's the average number of counts. Nope, I don't see it. Okay. What do we have? We have loop size samples, which are put into number of buckets. Thus, the number of bucket, that is like 1 over, right? It's the inverse of, so the count scale is now equal to 1 divided by the average number of samples per bucket. Yeah, we can just assume a uniform distribution. Of course, the count scale is not a function of what type of distribution it is. And then I want to get 1 if the count equals to 1 over this number. Which is why we divide by this, or rather, well, why this is the inverse of that thing. Yeah, okay. But why do I get 1? Because we have a width of 1. Well, we had a width of 1. So if my width is larger than 1, this must be less. Is not true? I don't know, it just feels like it. So I'm just gonna do that. Times buckets width. Yes, it seems to have worked, more or less. Well, it is triangular. And it fits on my screen. And the surface is... The surface is 1, right? That height looks like 1 point something, 1.2 something. Not 3. Well, let's say 1.25. 1.25, and the base looks like 2 times 0.79 or something, but then we have to divide it by 2 again. So let's multiply this by 0.79. And that gives me 0.9875, which is basically 1. Yeah, so this is the distribution of eta 1 plus eta 3. Empirically. Maybe it's not triangular. It's probably flat at the top. That's what it should be. If they are not exactly the same range, and they should not be. It's kind of coincidence, I think, that it is almost triangle. I'll bet it's a bit flattish. I'm going to make dinner, so let's just run this thing with a loop size that is 100 times bigger. It's going to take a while, which gives me the time to make dinner. I'll be back later. Make dinner? Put something in the microwave, I mean. Still not finished. Yeah. Doing exercises. Well, my computer is calculating. How long is it going to take? I mean, everything is cracking. What is the word for that? Dinner. Damn it, still not finished. And nobody knows how long it is going to take. Half a glass of wine, that's not enough. Okay. Hmm. Yeah, that was so stupid. Totally stupid. Oh shit. Oh shit. Yeah. My program is still running. It's taking longer than I expected. Dubious. No. No. Dang. Fuck, I wanted to go 2. Ah, there it is. And yes, it is flat at all. Tiny little bit flat. As expected. I feel I'm completely won here. I think I'm mistaken. Let's put it in the computer and then see if this is indeed completely winning. Before I did F4, I said that. Probably just going to push this. Not going to push it. Interesting. Wow. To give check here on the queen. It's just nonsense. Gives away annoyed. Oh, look at that. Still gives away annoyed. No. Thought I had a completely one position here. It's just 1+1. I did F4 and I'm even worse. That was a horrible mistake. Yeah, this gives away. Just gives everything away. No. The error in D4. Then first you have to calculate it. I guess like this. D4 is D2 plus D3. How's that going to work? D4. I get double D4 is something to double. Where the something is not mathematically precise, but just the floating point operation, which is D2 plus D3. So D2 plus D3. Which then we have to define. Now that's just going to be D2 plus D3, I suppose. And we need the exact expression for the sake of this calculation, which is just that times 1 plus that times 1, so that is C2x plus C3x squared. plus c3x squared to well, I'm using ops, but I'm using to the power of 2 like that. Just use epsilon. What is this? It's still the same thing. do D4. It's broader again. A normal distribution. Well, it starts to look like a normal distribution with a fat middle. Nou ja. Ja. This is D5, which is a plus, I think. D5 is C1 plus D4. This should be C1 plus, and then this thing should exist. Yeah, that's that one. So C1 plus D4. D6 is C1x plus C2x squared. Can't type. Plus C3 x to the power 3. Which is something times x. It's this thing times x. And the operation is d5 times x. Which is imperial d5 times x double d5 is d5. This is 6. Well, this is 6. D6 is d5 times x, but that's this. Round it off to a double. D7. To FA first, I guess. FA. I have not really. I need the full FA, which is of course C0 plus that thing, which is cubic of 0 plus that thing. That is exact. And then this is FA C0 plus D6 d0 plus d6. Yes. And broader and broader and broader. Should be within two. Yeah, no. Seriously, the thing has shifted? Why the hell is that shifted? Nah, must have been making some error here. Because it can never be shifted. Ever. Never ever. This is D6, huh? Yep, it is D6. D6. D6 is D5 times X. Rounded off. Do I also make use of no, this D5 is this, so C1x plus C2x squared plus C3x to the power 3. It's just this thing times x. Looks okay. That one looks okay. And that is D6 minus the exact equation. What about the absolute value of that? Scary. This is of course impossible. Did I not notice that 5 was shifted or something? At least 5 is an addition. Yeah, the D5 shifted. The arrow is in D5, or unless it is in D4 and so on. Now I'm going to be lazy, so I'm just going to check D4 first. You can hear that even one glass of wine is already too much for me. It's probably a good thing. Okay, compiled. It is compiled. This is not shifted. Okay, so indeed D5 is wrong. D5. D5 is C1 plus D4. C1 plus D4 rounded off. C1 plus D4. And then the exact value is C1 plus C2. But that looks okay. What are we doing? D5. C1 plus C2 times X. At least the name of the variable is okay. X is x, x squared is the square of x, c2x is c2 times x, c3x squared is c3 times x squared, C2x plus blah is yeah, and then C1 plus C2 blah 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 is C1 plus C2. Yeah, I don't see it. Well, not here anyway. Also not here. I don't see it. Maybe it's real. Maybe it did just shifted. The code is good. It's extremely unexpected. is seriously unexpected. It's so weird. Okay, I'm gonna look at FA. What the hell? I'm gonna do something else. Sleepy. Very sleepy. Right. I don't get this. Oh man. I'll get it tomorrow or something, I suppose. It's an interesting. Very interesting. Very interesting. I can totally not wrap my head around it. Why there would be a shift at the moment. I'll play until I lose, which is probably the first game, and then I'm gonna watch a movie. Let's give a comment here. Let's go for the center. It's possible, so yeah, to take towards the center. Guys, super. Droish. I want to play this pawn. It's probably not going to happen that I put it there. And then the question is, do I want my bishop here, or is it good enough here? I think it's good enough here. I don't have to decide yet, though. I can just put my knight there. Okay, this guy is totally going for this square. So his next move is this, and then he has his bishop outside of that chain at least. And then I can pin this thing and take it and double this pawn maybe. And the knight comes here. That this square becomes weak with the bishop there. Probably have to keep it out. This bishop cannot go here and not here, and it's a good bishop, so let's go here. Oh, I can't go anywhere anymore. Okay, that attacks are not particularly developed pawn, but I was thinking about this move. Defect, yeah, I has to move that one again. He probably gives check here, and then I just play my pawn up to 2. Or do I not? He could sacrifice it, give check here, and then I have to retreat with my bishop. And if he takes the bishop, I can take back with the knight. So my queen is still defending the rook. So it seems playable, and I win something with it. 1 point. Although I would prefer... developing. I can't do this, I just lose it. I can't defend it because the knight comes here. Well, I could take the knight then. No, because then this pawn chases my knight away and I lose this pawn. I think I'm gonna go for this idea. So then we do this. And then he sacrifices. And I put my bishop back. I was even mistaken. Okay, I had not seen this one. So he's trying to take here, I take, he takes, I take, he... Yeah, this one is in between. So even if I take with the queen, he can't immediately take my rook. Though he could pester me with this pawn, and then I lose the rook. I don't know, just... I have to castle. Let's do this. Is it possible? Why not? It should be possible. If it's not possible, then I'm losing anyway. Oh, okay. Yeah, that's true. That's true. I needed this one to defend that one, because now if he exchanges here, and even if I take back with the pawn or the bishop, then he takes here, and I can't even take back. Oops. That's not good. But then again, maybe I can just put my knight here, attacking the queen. Yeah, and then take there after that. Take. Okay, I lose that one. That's not working. Take. It's not possible. Defend like this. Also not possible. I get this pawn. We can go here with tempo on the queen. Oh, if he takes, oh no, it's also not possible. Fuck, I'm losing like totally. Are you kidding me, man? Aha, he had not expected the old king e7 move. Oh, he moved. What do? Just add another rook. Yeah, why not? Okay. Let's remove the pin. Take out the pawn and get rid of that thing, or take out the king and develop my bishop and keep my king safe, basically. I'm gonna go with that move. Didn't take anything, right? No. I have to move away. $30 left. It's not a lot. It's not a lot. It ain't a lot. Okay, let me go here. Thank you very much. Oh, wait a minute. That's a fork. Damn it. I did it again. Oh, no, I get check here. No, that was not good. Resign. You are dead. Yeah. Still, I'm going to win on time. I'm just going to win on time. It's easy peasy. I should have given check first. You moron. I'm blaming that on not having clocked. Not having time. Oh. I could have given check here, I think. That would have been not a bad move at all. What is he doing? Bum, 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 bum. Take your time. I'm going to win on. I am going to win on time. So yeah. I kind of have to. I guess he's gonna take here. He's not gonna take that. Oh, I'm so winning on time. He's not standing any chance, is he? Not standing a chance. Okay, that's nasty. What's going on, I suppose? Oh, he's getting nervous now because he's running out of time. Are we running out of time? Oh, I want that one. 2. And that one is fine, thank you very much. 20 seconds left. I have more time than my opponent. And he's like, shit, I lost a pawn. Doesn't matter that he's +5. He's just like, damn. Why? What happened? Pretty sure he's going to push that pawn. He's not going to push the pawn. Okay, now I'm seriously winning even. Seriously winning. Let's see. How do we win that? Take everything. He's kind of annoying, isn't it? Oh, I did not lose on time. Well, more or less he did. But I said I was going to play until I lost. Damn it, now I have to play another one. Oh, what am I doing? I gave away a pawn. That's no problem. I'm just going to win it back. Why is he giving check? It's annoying. Why? Giving check because you can give check. Well, yeah, I mean, I didn't even think about it. It's not threatening anything, is he? Not threatening anything. Oops. Fuck, I missed that one. Yeah, I didn't see that. He was threatening something. Okay, well, I lost, so I'm gonna stop. Let's watch movie. Movie time.